So in previous class we have studied the engineering classification of engineering parts, their steps, their and their also their procedures. In today's class we will go for the engineering methods. So engineering methods and their properties. To prepare a project or prepare a model, we require some engineering methods. So methods that helps us to prepare a model or prepare some parts. So the methods have some of their properties. So the knowledge of methods and their properties is of great significance for a design engineer. If a design engineer don't know that which material is used and which material should have used for this project, for this to make that material, to make that machine and make that some product, then he will be fair on that project. The machine elements should be made of such material which has properties suitable for the conditions of operation. In addition to this, a design engineer must be familiar with the effects which the manufacturing processes and heat treatment have on the properties of the metals. Now we shall discuss the commonly used engineering metals and their properties in machine design. As we know, there are different types of engineering metals and classification that we have studied in the previous semesters and classes. So now go for that. Classification of engineering metals. The engineering metals are mainly classified into metals and their alloys such as copper, iron, steel, aluminum, etc. Metals and their alloys. Non-metals such as glass, rubber, plastic, etc. The metals may be further classified as ferrous and non-ferrous. Ferrous metal and non-ferrous metals. So ferrous metals, that is the ferrous metals are those which have the iron as their main constituent. That is called ferrous metal. That ferrous is Fe. If Fe content, that is iron. Cast iron, wrought iron, steel, etc. The non-ferrous metals are those which have a metal other than the iron as their main constituent, such as copper, aluminum, brass, steel, etc. The material in which iron content is not a main material. The main materials should be like copper, aluminum, brass, tin, zinc, etc. These are called non-ferrous materials. Then selection of metals for the engineering purpose. The selection of a proper metal for engineering purpose is one of the most difficult problems for the designer. Before the designer go for a product to manufacture a product or manufacture a machine, that he should have such ideas on the metals, that which metal he should be selected for not. The best metal is one which solves the desired objective at the minimum cost, and he thinks and he should be think that which metal should be economic cost for that purpose. The following factors should be considered by selecting the metals. The factors are mainly three factors: availability of the metals, the metal is available or not, that should be checked. Suitability of the metals for the working condition in service. Metal suitability is the most important. That the material is in which condition, in which weather condition, and that it takes high temperature or low temperature. It should be metal suitable. The cost of the metal, the most of the cost of the metal. If cost of the metal is high, the production is high. If the cost of metal is low, the production cost is low. The important properties which determine the utility of the metal are physical, chemical, and mechanical properties. We shall now discuss the physical, mechanical properties. Physical properties of the metals. What is physical property? The physical properties of the metals include luster, color size, and shape, density, electricity, and thermal conductivity conductivity, and melting point. These are the physical properties of the metals. Color, size, shape, luster, density, electric and thermal conductivity, and melting point. Next one is the mechanical properties of the metals. The mechanical properties, what does mechanical properties says? The mechanical properties of the metals are those which are associated with the ability of the material to resist mechanical forces and load. The material which resist the mechanical forces and the load. This is the most important part. These mechanical properties of the metal include what is strength, stiffness, elasticity, plasticity, ductility, brittleness, malleability, toughness, resilience, grip, hardness. These terms we will discuss in next slide. So, in mechanical properties, what is the material to resist mechanical forces and the load. The material will resist the mechanical force and load, that is called the mechanical properties of the metals. Suppose we take a pen, we take a writing pen. That material is not much, the strength is good, stiffness is good. That is some the plastic pen, some elastic pen, or some plasticity pen, and ductility. There are brittleness will crack. Malleability, toughness, resistance, grip, and hardness. These are the mechanical strength. Strength. What is strength? Strength here. It is the ability of the material to resist the externally applied forces without breaking or yielding. Suppose we add some forces or load that will without that the material resist the force or load, external applied force, without breaking or yielding. If that is breaking, the strength is low. If that is not break, the strength is high. The internal resistance offered by a part to the external applied force is called stress. Suppose this is a block. We applied some forces, that is called stress. It gives us some pressure. If we put some pressure on that, if we load and hammer pressure, it gets internal reflection to the force and the metal is not break. That is called it has a good strength. The metal is good strength. Next one is stiffness. What is stiffness? It is the ability of the material to resist deformation under the stress. The modulus of elasticity is the measure of stiffness. The ability of material to resist deformation under stress, that is called stiffness. Strength completed, stiffness completed. Next one is the elasticity. As we know, elastic material are not breakable. That is like rubber. So, elasticity defines it is the property of the material to regain its original shape after deformation. A rubber, if you take a rubber, if you stretch it and just release it, it will get its original shape. That is called. So, it is the property of the material to regain its original shape after deformation when the external forces are removed. This property is desirable for materials used in tools and machines. It may be noted that steel is more elastic than the rubber. How the steel is more elastic than the rubber? Suppose we use some like suppose we give steel. When you press it, it will elongate. If we normally pour water, then we steel. Plasticity. It is the property of the material which resistance the deformation produced under the load permanently. It is the property of the material which retains its regain and it retains the deformation produced under the load permanently. This property of the material is necessary for forgings in stamping uses on coins and ornamental work, that is called plasticity. Next one is the ductility. What is ductility? It is the property of material enabling it to be drawn into wear with the application of a tensile force. A ductility material must be both strong and plastic. The ductility is usually measured by the terms of percentage of elongation and percentage of reduction in area. The ductility material commonly used in engineering practice in order to use ductility are mild steel, copper, aluminum, nickel, zinc, etc. and lead. When we make when we prepare some like cooking wares or some that is heat treatment process, that is called that the material used, that is that the property is called ductility. So in strength, stiffness, reduction, plasticity, ductility, strength is called what is it is the ability of a material the main thing is the ability of a material to resist the externally applied forces without the breaking or yielding. That is called strength. What is stiffness? It is the ability of a material to resist deformation under the stress. Then the modulus of elasticity is the measure of stiffness. That is the important modulus of elasticity is the measure of stiffness. It sometimes question which is the through which we can measure the stiffness. That is the modulus of elasticity. Elasticity, what is actually the property of material to regain its original shape after deformation when the external forces are removed. Okay? Plasticity. What is plasticity? It is the property of material which retains the deformation, produced under load permanently. And ductility, it is the property of the material enabling it to be drawn into wear with the application of a tensile force. The main term, these are the highlighted of the main term, the main parts defines the strength, stiffness, elasticity, plasticity, and ductility. And brittleness. Brittleness, it is the property of a material opposite to the ductility. Ductility means strong, brittleness means weak, or it might be brittle. Now it is the property of a material opposite to the ductility. It is the property of a breaking material. It is the properties of a breaking material. It is the property of a material opposite to the ductility. It is the property of a breaking of the material with little permanent distortion. Brittle metals are subject to tensile loads, snap off without giving any sensible relation. Cast iron is the brittle metal. If we hammering something in material like cast iron, if it will broke, then it will be brittle metal. If it will not broke, that is called ductile metal. So brittleness and ductileness is the opposite. Malleability. It is a special case of ductility which permits metals to be rolled or hammered into a thin sheet. A malleable material should be plastic, but it is not essential to be strong. The malleable metals commonly used in engineering practice like lead, soft steel, wrought iron, copper and aluminum, making a sheet, well sheet. What is toughness? Toughness is the property of a material to resist fracture due to high impact loads like hammer blows. The toughness of the material decreases when it is heated. It is measured by the amount of the energy that a unit volume of a material has absorbed after being stressed up to the point of the fracture. This this property is desirable if parts subjected to shock and impact loads. Next one is machinability. How do you machinability? It is the property of material which refers to a related case with which a material can be cut. The machinability of the material can be measured in a number of ways, such as comparing a tool like for cutting different materials or thrust required to remove the material for some given rate of the energy that is required to remove a unit value of the material. And it may be noted that the brass can be easily machined than the steel. So in this part, in brittleness, what is brittleness? The property of a material. It is the property of a material that is opposite to ductility. This is the most important part. It is the property of a material with a little permanent distortion. Breaking of a material with a little permanent distortion. And remember, cast iron is a brittle material. So next one is malleability. In special case for which permits the material should be rolled and have one dimension sheet. A malleable material should be plastic, but it is not essential to be stone. Okay. The examples are lead, soft steel, wrought iron, copper, and aluminum. Aluminum is soft dimension. Toughness. It is the property of material to resist fracture due to high impact loads like hammer blows. The toughness of the material decreases when it is heated. It is measured by the amount of energy that the unit of volume of the material has absorbed after being stressed up to the point of the fracture. So this property is desirable by solution to the shock and the impact loads. And again, machinability. Machinability is the property of material which refers to a related case with which a material can be cut. So these are the brittleness, malleability, toughness, and the machinability process. Next one. Then we go for resilience, grip, fatigue, hardness. Resilience, what is resilience? Resilience is the property of a material to absorb energy and to resist shock and impact loads. That is called resistance, like springs. It is the measure by the amount of energy absorbed per unit volume within elastic limits. This property is essential for the spring materials. When you go in bike, there is some when it goes on ducts like pressure, the shock absorber, that is the spring that you can say, the shock absorber of the bike gives this does not give shock impulse to the rider due to spring. When a part is subjected to constant stress at high temperature. When a part is subjected to constant stress at a high temperature for a long period of time, it will undergo a slow and permanent deformation, that is called creep. Suppose when we prepare a part or making a part of body, we give some constant temperature that produces heat, and that for a long period of time, not a short period of time, that it will go a slow and permanent deformation for creep. This property is considered designing internal combustion of engine, boilers, and turbines. That internal combustion engine to boiler turbine that slowly move the part. Fatigue. When a material is subject to repeated stress, it fails at stresses below the yield point stresses. Such that failure in the material is known as fatigue. The failure is caused by means of a progressive crack formation which are usually high and microscopic size. We know the diagram that is fatigue graph. This is the stress strain diagram. We know. Then next one is hardness. It is very important property of the metals and has a wide variety of meanings. It emphasizes many different properties such as resistance to wear, scratching, deformation, and machinability, etc. It also means the ability of a metal to cut another metal. The hardness is usually expressed in numbers which are dependent on the method making the test. The hardness of the materials may be determined by the following tests like this: Daniel hardness test, Rocker hardness test, and Vickers hardness test, also called as diamond hardness test. So in this resilience skill fatigue hardness, the most important part is that resilience is the property of materials to absorb energy and to resist shock and impact loads. This is the main part of the resilience. The main example of this is spring. Creep. When a part is subjected to a constant stress at high temperature, a longer time, it will undergo slowing permanent difference called creep. That is the when a part is subjected to constant stress at high temperature for a long period of time, it will undergo a slow and permanent deformation called creep. Examples are IC engines, boilers, and turbines. Fatigue. When a metal is subjected to a repeated stress, remember that line: repeated stress. If there are stresses below the yield point, stresses, such type of failure of the material is known as fatigue. Examples are shaft connecting the springs, gears, etc. What is hardness? And hardness in this hardness point, it is very important property of the metals that has a wide range of meanings. It emphasizes many different properties such as resistance to it. The main point of the properties such as resistance to it, scratching, deformation, and machinability. So the ability to metal to cut another metal, it is the main point. And you have to remember that. Next, working stress, yield stress, workload stress, and factor of safety. So these things are we going to study in next class. Thank you.